So the type of polynomial we're going to look at today, I say it's a new polynomial. It's actually not new. None of this is technically new, but it is a special polynomial that kind of deserves its own day. And simply, it's quadratic polynomials. Quadratic polynomials are pretty special. Again, we take a whole day and sort of give them some time. You've heard the word quadratic, at least you should have. Do we realize that quadratic, even though it's kind of a fancy math term, really just means x squared? X squared. When you have a polynomial of the degree x squared, basically it's special. It's special because there's options. And I want to spend a day kind of helping you guys remember the options for x squared. Now, when I say options, what I'm really referring to are the different ways that you can solve. Remember, back kind of from day one, which was really just a couple days ago, when we say solve, what we really imply is solve for the roots, for the zeros, for the x-intercepts. I don't write those directions down all the time. It's implied, though, that you're always solving for the roots. That's what you do with polynomials. Now, I'll kind of go through this. It's a little bit of review from a few days ago. It's going to tie into today. It all goes together. But if I ask you to solve, please make sure you realize that you actually have a graphing method. A graphing method is kind of handy. If the graph is helpful, and of course you need to have some way to graph it, like, Desmos or a calculator. I'm just going to wheel up the calculator here real quick. But again, if you type that into Desmos or into a calculator, you actually get a parabola. Okay? But what we really are focused on are these x-intercepts. Now, purposely, if you kind of look at those, I made it purposeful that you can't really tell what they are. I mean, it looks like it's something positive. If you're doing it on your own Desmos, maybe you can see a little bit better. But I don't know. What are those roots? We're actually going to kind of leave that hanging for a second, okay? Except to say that there was a graph and there were some x-intercepts. But again, we're kind of purposely saying, I don't know quite what they are. Of course, maybe you do know. Maybe you know because maybe you graphed it yourself. But let's go on to something else. Let's go on to another option. How about if we factor? Okay. Hey, listen, quadratics can be factored. I say often, not always. Okay, but when you have something of the x squared variety, in a case like this, you can actually use like a British method. Now, I did review that British method, but I kind of wanted to do one more problem because I know there's some of you that you're like, hey, can you go over that again? Yeah, if you use a British method here, you would multiply those outside terms. It always works like this. That gives you 12x squared. Then you would bring down those outside terms. So those outside terms have quite a bit a part of this method. I multiply them, I bring them down. Now, the part that you have to do a little bit of thinking is when you split up this 12x squared into two numbers that will multiply to be 12x squared, but will add to be negative 8x. Are you actually thinking about numbers that multiply to be 12 but add to be negative 8? Okay, we have to think about these numbers, and eventually you come up with negative 2 and negative 6. Yeah, negative 2x and negative 6x. They multiply to be 12. They add to be negative 8. Okay, now the fun's not over because the reason you did all this is so you could group. Now you group and you take out. Now you got to take out the best GCF of each of these groups. That's going to be a 2x for the first group. Of course, again, I keep saying you have to do that correctly or else things aren't going to work. So I take out a 2x, I'm left with 2x minus 1. Now over here, you kind of have to question, do I take out a 3 or negative 3? The answer to that is to make sure that you are left with the same thing, to make sure you're left with 2x minus 1. So if I do a little future thinking, I would want to take out a negative 3, again, because that leaves me with a 2x minus 1. I want to be left with the same factor. Okay, at this point, I'm feeling good because 2x minus 1 is the same. So you can set up your final answer. Your final answer uses 2x and minus 3. It uses that one time. And your final answer uses 2x minus 1 one time. You always use those one time. Okay, now remember, the whole reason that we set up these factors was so we could solve for the zeros. And the zeros, some of us might need to kind of think about this, I suppose, like a little bit off to the side. Some of us, maybe you can just do this mentally. But the zeros are going to solve each of these factors. Add 3 and divide by 2. Add 3 and divide by 2, and you get 3 halves. Add 1 and divide by 2, and you get 1 half. Now, if I did that a little too fast, please understand that I'm just solving each of those like it's a little equation. Okay, so these two numbers I just found are the sought-after roots. They are the zeros. They are the x-intercepts. So the mystery's kind of been figured out. We now have those answers. But the reason we're doing this today is because there's actually another method. There's another option. We have graphing, we have factoring. But listen, these are quadratic for a reason. And the reason is because they can work with the quadratic formula. The quadratic formula, all of a sudden that is up on the stage. Now, this is a superstar. Okay, so it's up on the stage. We got to kind of root it on. Do you remember the quadratic formula? If you've had me before, maybe you remember that I've said, and if you haven't had me before, I'll say it's something that you definitely want to know as a math student. In fact, you want to be able to teach it to your kids. Okay, it's kind of that important. You want to be able to teach it to your kids. If you don't want to teach it to your kids, don't have kids. Okay, the quadratic formula is kind of a big deal. It's something you have to know. It's a formula. It's a fraction. It's got a little bit of a style to it. I'm showing you that because I'm wondering if that rings any math bells. Ding, 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 ding. Don't call on me. But seriously, does this help you to remember? It always starts with something. It starts with the opposite of B. Very good. It's the opposite of B. Again, sometimes you hear this and it starts to come back, or it doesn't, but it's the opposite of B plus or minus the square root of. Now there's a 4AC, but it's not what comes next. So it's the opposite of B plus or minus square root of B squared. Good, B squared minus 4AC. This guy remembers it, okay? Make sure that all of you, as you write down these letters, that it's coming back to you. And if for some reason you've never seen this before, this again is a big deal. It's all divided by, this is kind of your last chance to remember the quadratic formula. It's all divided by 2a, all over 2a. Quadratic formula. Jokes are made about it. Here's one of them. Yeah, homework helpline. I need you to explain the quadratic equation in roughly the amount of time it takes to get a cup of coffee. I don't know. I thought it was kind of funny. Okay, this guy's having trouble teaching it to his kids. So comics are written about it. Songs are written about it. X is equal to negative B plus or minus the square root of B squared minus 4AC all over 2a. And of course, I want you guys to know it. Okay, now here's the deal. The quadratic formula is another option for a quadratic. Okay, make sure that you get that amidst all the other stuff. So let's do that option. Okay, that means I'm going to plug in these numbers for a, b, and c. And I would expect that you realize that a, b, and c are the coefficients, so it's the opposite of -8. Oh, the opposite of -8 is +8. As the song goes, plus or minus the square root of, okay, so b squared, -8 squared, minus 4ac. Now, of course, all over 2a, so all over 2 times 4. Depending on sort of your memory of this is the part that matters. Like, you got to be able to do 8 squared minus 443. Hey, I don't care how you do it. I typically will show this as a little bit of a breakdown. Like, I will show 8 squared to be 64, and then 443. Well, that's 4, that's 16 times 3, that's 48. So for me personally, I kind of like to see these numbers. How do you want to do it? If you want to break out a calculator, again, it doesn't matter as long as you can do it. Eventually, we need to arrive at the square root of 16. Eventually, we arrive at the square root of 16. Make sure you arrive there. All right, and I'll give you a problem to practice. Once we get kind of to this step, it's a matter of just simplifying so that we understand that this thing's supposed to turn into 2 answers. Okay, the square root of 16, well, you can actually do that. So do it. The square root of 16 is the number 4. So that would be good. Again, we kind of get to this step and we have to realize that thing's going to turn into 2 answers. It's 8 plus and 8 minus 4. That's pretty important. Let me say it again. It's 8 plus 4. That's 12. It's still over 8, though. And it's 8 minus 4. That's 4. And it's still over 8. Okay, so this thing represents 2 answers, which I hope you're making a connection, are the same answers that we did find already. We found them over here. Okay, and by the way, we were hoping for 2 answers. All along, this thing was quadratic, so it's got a fundamental theorem says I've got 2 answers. Now, maybe you're saying, well, but I don't need the quadratic formula for this problem. No, you don't. You don't need it because we had other methods, but there are some problems that you need it. The reason you need it is because the answers aren't real. It's important, okay? You have to understand that if I give you a polynomial like x squared plus 2x plus 2, now, as you're copying it down, maybe there's nothing that is a big deal, or maybe it doesn't seem like there's anything wrong with it. Well, there's nothing wrong with it. It's just that you can't factor it. Okay, you can try as hard as you want. You can't make that work. The other thing is when you graph it, you do not get any roots. Okay, I'm going to save a second from pulling over the calculator, but if you do type this in your calculator, you find out that the only option here is to use the quadratic formula. Now, that's fine. That's kind of what the quadratic formula is for. It's able to handle any quadratic equation. Try it, okay? This shouldn't be your first stint with this. Plug in the opposite of b. Plug in b squared. How far can you get with simplifying this? What do you think about just the numbers? Are you matching with simply plugging in? 4 minus 8. Okay, 4 minus 8. Actually, as you start to understand the big picture a little bit better, you say, yeah, I'm not surprised that I'm going to get an imaginary answer. The reason you're not surprised is because you were unable to factor it. You were unable to graph it. Okay, so the answers have to be imaginary. So we get to the square root of negative 4. We don't flinch, or at least get too worked up. First of all, the negative is what's going to be imaginary. So you kind of like take out the negative. You think of it as the letter I. Now, once you get that letter I, you need to take the square root of 4. The square root of 4 is 2. So really, we end up with 2i. And you can just jump right to 2i if you'd like. Now, there's a lot of 2's up on the board. This problem was designed that we would be reminded that you can and should divide by 2. You're allowed to divide by 2, like I'm showing here, kind of like a heart method. So you get a more simplified answer, most certainly. You get negative 1 plus or minus I. Now, the answer is a little goofy, but it's called a conjugate. That means that it's got that plus or minus look. We did say the other day that imaginary numbers always have that look. Just so you know, the two answers are negative 1 plus I and negative 1 minus I. Technically, the two answers are the plus and the minus. I'm not going to make you split it up necessarily, but you need to understand what that means. There's one more problem that I have in my notes. It says, make sure you do this. So remember, there's a little mini check. As long as you have about 10 minutes, which we will, you guys will be fine. But I want to make sure we do this problem. Okay, now careful. It says 2x cubed, 6x squared, 6x. Two x cubed, 6x squared, 6x. Remember, the directions are like the same for the next couple days. Solve, find the roots. Okay, find all the zeros. You can pretend it says equals 0, but you know, it's still the same thing. Don't plug this into the quadratic formula. What? Hold on a second. It's not quadratic, it's cubic. Now, that should catch your attention because that means there's 3 answers. And again, I can't plug it into the quadratic formula, but you can. Okay, now this problem is meant to help us start to put multiple things together. You can factor, like basic GCF factor, like take out the extra, sort of the extra weight, take out the 2x. I don't know if that was the first thing you were thinking, but it needs to become the first thing you think before you jump into other things. Always think about basic tools. In this case, I can pull out a 2x and I'll get x squared, 3x, and 3. Now, do you understand that what is in parentheses is quadratic? That means that what is in parentheses is worthy of the quadratic formula. Same thing. Can I encourage you to practice that one more time? Do you want to plug in those numbers into the quadratic formula? By the way, if you're wondering about that 2x out there, don't forget about it, but that 2x is not part of the quadratic formula. Okay, we get 9 minus 12. Again, make sure that you, whatever you're doing, whether you're using a calculator, doing it like I'm doing it, but that you get the square root of negative 3. Square root of negative 3, as well as the other parts of that quadratic formula. kind of get to that and you're like, ugh, did I make a mistake? Okay, but you did not. You get an imaginary number. There's actually only one more thing that you can do. You should do it. You should say that the square root of -3 is I root 3. All I really did was take out the negative and turn it into an I. Please leave the other items there. Sometimes students will ask, what if you can't divide? Like here, you really can't divide that and get something simpler. Nothing happens here either. So since you can't divide, you don't. You just let it in this kind of this strange form. Well, it's not really strange. It's just known as a conjugate. You have a plus or minus. It's all divided by 2. It's fine. Okay, now remember, we're trying to solve for the roots. There were 3 of them. I have 2 of them right here. That's good. I got 2 of them, but there's one more that comes from this. This is the one that's sometimes forgotten. So sad. It shouldn't be forgotten. What makes 2x equal 0? Don't say -2. Do say 0. X equals 0 is the other root that goes with that factor. Just to emphasize with the box, we've got our 3 factors. All right, and now the fundamental theorem is satisfied. Hopefully you're feeling good. And I guess for a little icing on the cake, you could graph it. Now, when I say graph it, you could graph it on Desmos, but the idea is that you should understand that what you just did is to help you graph it. X equals 0. X equals 0 is the only real root. Okay, that means that I can look at my leading coefficient and say that it's going to go up. I can look at the degree and say it's opposite on the other side. And really, the only thing that happens here is that I pass through this intercept. Don't worry, there's nothing else that you would show. These imaginary roots don't show up on that graph. Like I said, if you pop that in a Desmos, you'll see the same thing. Okay, you're allowed to do that. Quadratic formula. Make sure you can teach it to your kids. Make sure you can use it on the homework helper. That would be, let's do that first.